The researchers claimed that the average income of the town's resident is at most $60,000. You surveyed 40 residents from the town and found that the average income is $63,500 and the standard deviation of $12,000. Assume we already determined the hypothesis. The null hypothesis is mu equals 60,000 and the alternative hypothesis is mu greater than 60,000, and we also determined the test statistic t equals 1.845. Compute the p-value for the hypothesis test. We established that this is a t-test for the population mean. The t-distribution is very similar to the normal distribution. It is symmetric for the right tail test because the alternative hypothesis is mu greater than. With the computed t-test statistic t equals 1.845, we're looking for the corresponding p-value, and we can do this either using the t-table or technology or a calculator. Regardless of which method we're using, we would need the degree of freedom. The degree of freedom is always n minus 1, but n is the sample size, n equals 40, and so the degree of freedom is 40 minus 1 or 39. We will use technology to compute the corresponding p-value for the test statistic t. Specifically, we will use StatsCrunch t calculator. If we pull up the free online calculator StatsCrunch t calculator, we will see this window. We will need to input the degree of freedom, which is 39. And we will select the inequality greater than or equals because this is the right tail test. We would also need to input the test statistic t 1.845. What we're doing here is that we're looking for the probability that the x value is greater than or equal to 1.845 with the degree of freedom 39. We hit compute and we see that the calculator will give us the corresponding probability, which is the area on the right hand side of the test statistic t. And that area, that probability, that p-value is 0.0363. And we conclude that the corresponding p-values for t greater than 1.845 is 0.0363. In the t calculator, they use x, but this is the t distribution. If we were to use the desmos calculator for the t-test, we would need to specify the t-test statistic, which is 1.845, and the sample size, not the degree of freedom, but n. N is the sample size. With this particular test, we have three options, whether it is the right tail test, the left tail test, or the two tail test. In this case, we are performing the right tail test, so we will select the folder with the right tail test and expand it. We see that the corresponding p-value is 0.0363, rounded to 4 decimal places. This value is known as the p-value for the hypothesis test. If we were to use the t-table to look up the p-value for the corresponding test statistic t equals 1.845, first we would locate the degree of freedom. In this case, the degree of freedom is 39. We would stay on the line with the degree of freedom 39. In some cases, we might not the exact degree of freedom. We would need to round it to the nearest, to the closest degree of freedom. Observe that the test is the right tail test, so this is the one tail test, and so we would need to obtain the corresponding p-value in the one tail area in one tail section. There is no such t-value 1.845 on the line with the degree of freedom 39, but we found two t-values that are closer to 1.845. The t-values are the numbers inside the table. Those two t-values are 2.023 and 1.685. The corresponding p-value to the t-value 2.023 for the one-tailed tat is 0.025, and the corresponding p-value for the t equals 1.685 for the one-tail is 0.05. And so even though we do not have the exact p-value for the corresponding t equals 1.845, we can certainly say that the p-value is between 0.025 and 0.05 for this specific t-test statistics. For our purpose, this is good enough. The p-value that we found earlier using technology, it was 0.0363, and that value is the exact p-value for the test statistic t equals 1.845 with the degree of freedom 39, and that value is between 0.025 and 0.05.